Welcome one more time to an episode of Dave Does Math from Home. This is part 3 of our video series on related rates, where we do implicit differentiation style calculus on story problems to see how moving parts come together. Today I want to talk about area. So we have this problem. A triangle is being squished. The length is increasing at 1 centimeter per second while the height is decreasing at 2 centimeters per second. How fast is the area changing when the length is 5 centimeters and the height is 6 centimeters? So, the first thing we need to do to solve this problem is draw a picture. We have a triangle. Here's my triangle. The height is 6 centimeters. The length is 5 centimeters. The length is increasing at 1 centimeter per second, and the height is decreasing at 2 centimeters per second. This kind of looks like the ladder problem now that I'm thinking about it. But instead of this being a constant ladder length that is forcing these rates to be connected, this is just a abstract shape that we can sort of play with and manipulate how we want. So this is increasing while this is decreasing. And now I'm interested in the area. So we're going to end up using a different equation for this. The relationship between the sides is not something I care about anymore. That's something I cared about in the last problem. It's not something I care about in this one. In this one I care about the area. So we're going to have to use that formula. The area of a triangle is 1/2 base times height. So this is the relationship between the 6, the 5, and the area. We can see from this that the current area is 15. That's not what this question is asking for. I should mention that as part of this video series. Every time I give a test on related rates, someone will just do the area formula and like plug these numbers in and say the area is 15, and then they think they're done and they'll put a box on it and they'll go to the next question and they'll get basically 0 points. I don't care what the area is. That's not what this question is asking. This question is asking how fast is the area changing? And for that, we need to do some calculus on this guy. The derivative of this whole situation should give me, derivative of a is dA. 1/2 is a coefficient that can hang out. B times h is a product. That means that for this we have to use the product rule. So first times the derivative of the second plus the second times the derivative of the first. This is base times d height plus height times d base. This is the equation I need to be working with. I think we've reached the point where we've run out of room to comfortably write things, so hopefully you all remember this. I'm going to erase it. I'm going to simplify this just a little bit. dA equals 1/2 b dh plus 1/2 h dB. This is the formula that connects the changing rates of all three of these things. The area is changing as the height and base are changing. So we need to figure out what of these things we know, what we can figure out, and how we answer this question. dA is the question. That's what we don't know. That's what the question is asking. How fast is the area changing? The base we know is 5. The change in height is, this is decreasing at 2 centimeters per second. So here's where you have to be really, really careful. And this is a very important point. It's the only time it's going to come up in this video series, so pay very close attention. DH is -2 2 centimeters per second. In the last video I spoke very briefly about whether or not it makes sense for certain things to be negative or certain things to be positive. That's something you have to constantly be paying attention to in these problems. If something is decreasing, that means that that rate of change is negative. If something is increasing, that means that that rate of change is positive. So you have to keep that straight. H, we know, is 6, and the change in base is positive 1 centimeter per second. So, I have these 4 pieces of information. I'm missing the 5th, which works out because I have all of these things and I need to find this. So let's just do some math and see what we get. dA equals 1/2, we said the base was 5, times negative 2 centimeters per second, plus 1/2, the height is 6, and dB, or 6 centimeters I should say, and the change in the base is positive 1 centimeter per second. So, this is 1/2 times 5 times negative 2 should be negative 5 centimeters squared per second, plus 1/2 times 6 times 1 is 3 centimeters squared per second, for a total change in area of negative 2 square centimeters per second. This is how fast the area is changing on this triangle at this moment with these rates. That'll about do it for our section on related rates. There are more kinds of problems. That's the beauty of story problems, right? There's lots and lots and lots of different kinds of story problems you're going to see in this section. This is just a quick sampling of some of the major types you'll see, so that you can get in the habit of drawing a picture, finding an equation that relates quantities, taking a derivative of that to get an equation that relates rates, and then plugging stuff in. That's how you do related rates. Homework should provide you lots more practice. You'll need it. These get messy.